All right, you are welcome to proceed. Thank you so much, Ron.
Okay, thanks for having me. So this actually started as an answer to a question from one of my sons who was working at a consulting company where they primarily did software development. And he said, "Dad, we get lousy requirements or no requirements. Can you come speak to our company about what we do when we're pretty confident we're not getting good requirements?" And there's books out there on requirements, elicitation, and so forth. But what I want to speak to is what's behind that. I will eventually get to requirements because most of you know me about that. I do have a YouTube channel on my own, and this has all of my NCOSI presentations on requirements over the last 25 years. There's also a series of articles on LinkedIn. The first one is about which comes first, functions or requirements. And then there are a few other things. So I will be getting to requirements eventually. I really appreciate Mav's presentation this morning on ears and patterns. And we did something similar at the Boeing Company, and I'll touch on that later. I want to talk about how we can avoid rework. And avoiding rework is getting the problem properly defined. And a feature of a lot of software development is you do something and it's not quite right, so you can redo it. And the rapidity with which software can be developed and updated makes that possible. And hardware has a bit larger constraint, which is it takes longer, especially when it comes to electronic circuits. I will say mechanical engineering, the additive manufacturing and 3D printing has made it possible to make changes quickly, but that doesn't work very well for printed circuit boards and electronics. So we want to get clarity about what needs to be done. So I'm going to talk about the problem, what some impacts and options are, how can we go about addressing ambiguity, and then I'll get into some discussion about requirements. Well, several problems happen when you go and talk with someone about developing something, because first, clients think they know what they want. They may not be able to communicate it very well, but they think they know what they want, at least at that moment, but it's likely to change over time. And so we've got have to have a way of dealing with that. Another reality is clients may be unable to describe the problem they want to solve. In contrast, at best, they may be able to describe features of a solution without actually telling you what problem is being solved by that solution or that approach to a solution. Clients may think very narrowly about a single class of stakeholders, and that's going to be primarily themselves as users. In one sense, we were just having that discussion in the prior panel discussion where we put ourselves mostly in the class of users, and the panelists are in the situation of suppliers trying to interpret what we think we want based on what we tell them. Like, we want it more user-friendly. And the first thing I'm thinking of was, well, how would you know? So that's a real-time example of each stakeholder community thinks about the problem and solution from their own perspective. We're not going to do anything about that. I mean, we can't fix that because that's a reality of who we are as humans. We look at issues from our own perspective. So if we're users, we may not think about maintenance or testing or anything else like that. You know, contractors think about solutions in terms of design details, and architects want to, this is building architects, want to know how you're going to use the space. And so it can sometimes be hard for contractors and architects to talk to each other. My son is an architect, so I hear about that. So what can we do? Well, there's some pretty standard options and approaches. There's the work to contract. These are the requirements the client gave me. These are the only things I can work to. And of course, I heard that a lot being a part of a supplier for many years. And I heard that from project managers. We're not to touch the requirements because that's what the customer gave us. Or we can't do anything until we're sure we have all the customer requirements. I call this the Wally syndrome. We'll just wait until we think we have all the requirements before we start doing any work. And that's clearly not going to suffice. The client doesn't have time to give us requirements. We'll just have to guess. And this can happen frequently in consultant-client issues. A solution is desired for a problem, but there's no definitization of that. And that's very frustrating for the people that are trying to help solve the problem. We need the client working with us each day to try out our deliveries and give us feedback. And this is essentially agile development. We can skip the requirements. We'll put out working code and let the customer tell us what they like and especially what they don't like. And then we'll just rework it until they run out of money. So that's an option, and that's a high feedback thing, but it does require strong engagement by the client. Another approach is we recognize the potential incompleteness in the requirements. We will coach the client into disclosing what they know and think and imagine. And that's what I'm going to focus on for the rest of this. And if we adopt one of the other approaches, we're going to have dissatisfied clients and dissatisfied consultants because the project won't be successful. And you've probably read about the numerous studies about project failure rates. And this isn't a new problem. I've used this slide over a number of years, but it first came out in 2006. The client wants some software. What are you trying to accomplish? I want you to design my software. Well, what do you want the software to do? Well, I won't know until you write it. I can get the software to do anything you want it to do. You just got to tell me. Well, can you get it to tell me my requirements? Well, obvious answer is no, but this is 15 years old, and Scott Adams had experiences with multiple companies and coming up with this. So we've got to figure out a different way to come up with sets of requirements when we start with incomplete or inadequate requirements. I put this flow together a few years ago to speak to how do we get to eventually to valid requirements. And we get to valid requirements not by starting with customer requirements and working straight down, but by starting with some analysis of what's the need, what are the desired capabilities, what are the measures of effectiveness, how do we measure success, what are the concepts of operations. We are sometimes given requirements, and a standard approach is to simply decompose, decompose, decompose. But in the absence of analysis, we have no idea if those are correct or complete or valid or even ultimately going to deliver the capability that is elsewhere stated as desired or required. The better process is we start with what the needs are and quantify and definitize those and analyze and write requirements at the operational level, and then derive and analyze architecture at succeedingly lower levels in the architecture. And requirements trace is not just to the parent requirement, but it's to the source of the information that allowed us to write the requirement in the first place. And a couple of presentations I have in the YouTube channel are about using the architecture to provide the information for writing good structured requirements. To follow along Stephen Covey, what we want to do is begin with the end in mind by asking questions of the clients, because clients, like most humans, like to speak in terms of nouns and solutions. So when the problem is solved, I'll have something, some sort of a widget, and it'll do something. So before we get to that stage, we have to do hard work of asking clients questions that maybe they've thought about, but not real deeply or only in the back of their minds, because they're thinking in concrete terms about nouns and solutions. So questions we can ask: what problem are we trying to solve? And that may be too white space or whiteboard for most people. So another one is, if we solve the problem, how would the universe be different? Or what would we see or observe or measure that would indicate we had made a difference in the problem space? And this gets to the measures of effectiveness. Being able to attempt to quantify actually helps us define the problem. And this is a feature of Six Sigma: define, measure, analyze, because part of the problem definition is defining the measurement attributes, what's currently not so good, and how we want the solution to improve that. Concepts of operations and the other concepts. How will you and others use the solution, whatever it is eventually? How are you going to maintain it? How are you going to test it? How are you going to dispose of it? How are you going to upgrade it? Can you describe a day in the life of this system? Because there are probably things going to be offered in that discussion that are not in the requirements and perhaps haven't even been thought about by the client. With what other entities or persons must the solution interact? And here we're getting into inputs and outputs that are going to be the source of triggers that Mav discussed and the source of observable outputs from the system that eventually appears. And what characteristics of a solution are absolutely critical for this project? There may be solution constraints that truly are requirements, because if you don't have them, then it's not going to be a valid solution. But it's important to be able to differentiate absolute criticality from desirability. So here's a simple example. Starting with perceived needs. I need a new car. And you can immediately think, oh, well, here's a catalog, how much money you got, you know, do you want a European car, a Japanese car, a US car? Rather than discussing the solution space, the system engineer should pay attention to, well, how do you want to use it? You know, so without getting into models and manufacturers and price, first figuring out, well, what does somebody want to do with it? And we get an answer, oh, I'm going to use this in my business to show clients available real estate. So implication is I've got to haul some people around. How many clients do you need? And what other characteristics are most important would be a reasonable response. Well, I've got to hold up to 4 people and it has to communicate success. So that's what we call a non-functional requirement in value engineering. That's one of those aesthetic requirements, but that may be mandatory because it has to communicate success. So no 20-year-old beater is going to work here. So we might offer, well, here's something, you know, it'll hold 4 people and then some. And, you know, if it's Cadillac, that most people associate that with success. On the other hand, they may say, I need a new car to get to work. And you can go through some discussion about, well, what time of day, how far do you got to travel? Do you have to carry stuff? And you may say, you know, how fast, how often? You might say, well, you know, what you really need is a bus. You don't need a car or other vehicle. You just need to use the transit that's available, because there's a bus stop a block away and it comes every 20 minutes and it'll get you there in 25 minutes, no problem. And you don't have to pay for parking and a whole bunch of other good stuff. So I don't try and argue with people, but I never ask clients about requirements. I never ask them what their requirements are, because they don't really know about requirements. That's sort of my job. And so in the absence of client input, in other words, if you can't get at them to answer these questions, then you're going to have to infer. And that's a challenge. That creates risk, of course, but you're going to have to figure out, well, who are the users and other stakeholders and what do they care about? terms of the problem space and measures of success, and how are they going to use the new system, and what are the critical characteristics. And these are really acceptance criteria. If it doesn't have it, it won't be acceptable. And are there any constraints on the solution? And from this and any conversations, and the consultant has to develop and then validate the requirements with the client before proceeding. In other words, we have to do our best job to figure it out and then reduce that discussion and that analysis into a set of requirements and offer that and say, will this satisfy your problem that we're trying to fix? So I put together in one slide a summary what I just went over. The client meeting checklist. What is it you don't like about the current situation? What's the problem you think we're trying to solve? How are you going to use it? Can you tell me a story about the day in the life? What are the measurable results? This is really, really important. Not just functionality, but performance attributes and observability. What would be able to see or observe and measure? And this is about what the level of the requirement statement is. External interfaces. What other entities and persons have to interact with whatever the solution is? Are there existing interfaces or applications or other systems with which the solution must be compatible, like backward compatibility? Are there any important environments, like do you have to do maintenance 20 below in a snowstorm? Maybe, be good to find that out ahead of time. What characteristics of a solution are absolutely critical? There probably are some. There may be regulatory things, there may be standards. It's good to find those out ahead of time. With respect to software, and almost all our systems have software. Simple questions about host operating system, version, hardware, minimum processor capabilities, networks. These have huge impacts on architecture choices. And we don't always understand that until we try something out and it doesn't work in the particular environment. Well, we didn't know it was going to be in that environment. And is there required programming or modeling language now that we're doing modeling? And more generally, why is this constraint or characteristic absolutely required? And this is an attempt to get at the difference between requirements and desires. Because if we focus on the minimum set of actual requirements, we'll probably end up with a smaller list. And that does a couple of things. It makes it less expensive to do the development. It also hugely opens up the trade space of solutions if we don't artificially constrain the solution space because of desires that aren't truly acceptance criteria. So I always talk to my students about acceptance criteria, that requirements really are the acceptance criteria. Are there any allowable options or variations? Maybe you've got preferences, or maybe you even have mandatory features, but are there allowable variations that might still be acceptable? Most people have a difficult time talking from a blank sheet of paper, but if we propose things, people are more than happy to tell us why they don't like what we're saying. So you just have to have a thick skin and write it down. So what I urge is what I call a more linear two-phase process, rather than building it and finding out that somebody doesn't like it. We start by identifying the needs and defining the requirements based on our client interview and analysis, then write those requirements and validate them with the client and any other stakeholders. And you do that as much as you need to until you and the client agree on this is the right set of requirements. Then you go ahead and build and deliver, because there's extreme risk in skipping the validation. If you run immediately from requirements to build, you'll likely build something that isn't quite what the client desired. And we want to avoid this large iteration, which certainly for systems and hardware, this is a long schedule thing. It may be shorter and is actually a feature of agile development. Build it and see how the customer likes it. What requirements require is that we have to be able to come up with a set of mandatory acceptance criteria. And our paper from 2015, and there is a video on the YouTube channel for this paper, we went through the Boeing approach to structured requirements and how we developed a way of improving requirements quality. And I will say at the outset, we started this journey on the basis that if the requirement is not conceptually verifiable, every other consideration is moot. In other words, if you couldn't prove whether it was satisfied, then you probably have other problems, like you can't observe what it's doing, observability of function. There's no measurable attribute, so you could tell whether you're successful or not. You don't know when it's supposed to happen, conditions and triggering events, and you don't know what kind of an output you really require in terms of a specific kind of an interface, whether it's display or digital. So we want to address which specific characteristic we need to talk about. And we clearly want to differentiate the mandatory from the preferred. So one question, if the solution doesn't have that feature or characteristic, would it still be acceptable? And why or why not? This is a quick way to get at the idea of mandatory. And mandatory is the basis for having a requirement. I had a long discussion with a member of the requirements working group 20 years ago. And when I forced this issue, he said, Ron, the horse is already out of the barn. Requirements deal with not just mandatory characteristics. And that's a problem, because if all they describe are desirable design features, then it's almost impossible to figure out what the minimum set of, quote, requirements is. And you end up with such oxymorons as tradable requirements, which means they're not mandatory at all. My coaching is there should be few requirements, but they should be mandatory. Everything else is either preferred solution or design description. Shall or some other word connotes mandatory, and that should be stated in the specification. So I noticed that Mav was using shall this morning, and most people do. Apparently the US Supreme Court has decided that shall is not a mandatory criterion. And so some of our regulatory agencies in this country are pushing must. But it doesn't matter what the word is, you just need to identify it clearly and consistently use it, and use something else to define optional characteristics. So characteristics are either requirements or their preferences, and they should be clearly delineated differently. So viable solutions must satisfy requirements. And if you miss a requirement, you don't have a viable solution. It's not acceptable. And if any requirement doesn't precipitate that result, then it's not really a requirement. Like, well, I have to absolutely have 1,000 hours mean time between failure. Oh, we only get 800. Well, then that 1,000 wasn't a requirement. And I'll bet you if you got them down to 500 hours, they'd accept it. Big problem in life cycle maintenance for systems. The basic structure I learned is a variation on what came with ears. The who, shall, what, how, well, under what conditions. For a long time, we experimented with having the condition statement up front, because that really satisfies the logical syllogism of if then. But what we found was sometimes our condition statements, including trigger events and states and so forth, became so long and complicated, it was hard for people to find the shall. So we settled on a standard set of structures that always begin with the who shall. And every one of our structures, and we developed 4 patterns at the Boeing company, follow this construction. So we have the functional performance, the agent shall function in accordance with interface output. There's the observability with performance. And if it's a triggered event, then it's going to have 3 other pieces: a trigger event, a timing, and associated trigger input interface while in condition. Now we chose the words while for a state condition or a precondition, and rather than when, we chose upon, because we found that there were interpretive differences about the use of the word when. So we found that upon more effectively bespoke a triggered event rather than when, because sometimes when got interpreted as a state condition. And we never used if for a anomalous condition. Design requirements having to do with constraints on the solution. Simply, the design shall exhibit some constraint, and there may be optional performance and condition clauses that go along with that, like the dry weight has to be less than a certain number of pounds. Environmental requirements, which we realize are primarily statements of conditions that apply elsewhere, but we felt it was a bridge too far to eliminate a whole class of requirements that were standardized in all the templates and our customers were used to seeing. So we focus on clearly defining what the condition statement is and associating that with some specific characteristic or set of characteristics during or after exposure. And the last one is a large group of what we call suitability or fitness for use requirements that are not mission specific. And these will include such things as safety and reliability and availability and transportability, but they have some definable characteristic on the whole, and they have some performance characteristic, some performance attribute and a condition statement and a possible condition duration. And I see there's some questions popping up in the chat window, and I'll take those at the end when we get there. So some simple examples, and I put the system shall here just for making it generic, but these are color coded to help us see, rather than using the carrots, what the different parts of the requirement. So I've got a function, I've got a performance attribute, I've got a condition statement, I've got a trigger event. So I've got measurable attributes. So this is for somebody who needs to get from point A to point B. So maybe I don't need to say they need a car. I just need to say, well, what does the user need? And they need to get to a selected destination within a certain period of time out to a certain range with high reliability, you know, because cars break down just as much as buses don't show up. And they've got an hour to do that. And there has to be consideration for natural environments and the time of day they need to do that. This captures the user need and opens up a huge trade space. You know, I read that Boeing is now just invested in a autonomous aircraft for taxi service. Okay, so we could do that, or Tesla's got autonomous vehicles pretty soon, or Google or Apple or any one of those others. So the point is, it may be your personal automobile, or the solution might be a zip car or an autonomous vehicle that shows up, or Uber or something else, or even a bus. But this expresses the need in quantitative terms. As far as design constraints, the system shall be built in C#, some version, and that may be a mandatory characteristic, because that's no solution would be acceptable without it. Or environment requirement, satisfy all functional requirements, and we'd have to state which ones those were, during and after exposure to a denial of service attack that got defined somewhere. That's an example of an environment requirement. Or a suitability requirement, availability greater than a certain threshold during any 1 year period, and then a condition statement of it is powered and it's exposed to a certain set of environments. So how do we find all the requirements? So this is my first job on the requirements working group going back to about 2000. I'd actually started working on this ahead of time in my first NCOSI papers. Well, the more ad hoc way is to simply identify critical to quality characteristics based on our client interviews and user stories and ConOps and templates, and hopefully we found all of them. What I discovered was you actually can define it formally and mathematically provably based on sets of interface conditions, but it does end up being rather daunting to come up with that. And so there are papers in NCOSI and one comment in the System Engineering Journal, and all these NCOSI papers are in the YouTube channel, and you can see those, two specifically on requirements completeness. Then we started, so I mentioned we first started worrying about verifiability. In other words, is the requirement stated such that you could determine whether you pass or fail? And if it's not, then the first thing to fix is verifiability. And a couple of years ago, I did a paper with Bob Noel from Boeing Company, and we addressed what we thought were 4 necessary characteristics to ensure validation, validated requirements. And we also mapped these to the 14 requirements characteristics in the NCOSI guide for writing requirements. But validation is about ensuring a correct set of correct requirements. So the set is correct and complete, and every requirement is correct, meaning it satisfies the criteria for a high quality requirement. We tumbled to this correct and complete language in part because of commercial airplanes' use of ARP 4754A. They didn't talk about validated requirements, they talked about correct and complete requirements. But we concluded that we needed to establish a correct set of correct requirements as being a valid set or a correct and complete set. And one of the features is there cannot be any unnecessary requirements. We also realized that correctness includes completeness, because completeness requires that there be nothing missing as well as nothing in error. So we tumbled all this together, but we derived 4 criteria about validation: verifiability, necessity, in other words, a solution won't be acceptable without it; sufficiency, in other words, if we actually implemented that requirement, will satisfy all the defined system needs measurably; and then feasibility, which is a check on the solution with respect to the rest of the program and the rest of the design. So the checklist we have, first, is it a mandatory characteristic? And if it's not, then you don't need it. It's unnecessary. Verifiability, is it written such that it could be objectively confirmed or falsified? And it better be yes. And just Pascal's question, the on validation and verification of the requirements, yes, we dealt with that in the NCOSI paper from 2018, but I don't have time to go into that level of detail here. So thank you for that observation, but we did address that in the 2018 paper. The necessity, could we satisfy all user needs even if we deleted it? And if it's necessary, then the answer to this is no. And if the answer is yes, then you need to delete one or more requirements. In one of the requirements workshops we went through, trying to apply our requirements measurement methodology and these structured requirements, we found on average, we were able to delete 40% of the requirements in the supplier specs because they had simply been accreting into existing specs, new requirements from the new program, and not examining the requirements to see if they were that topic, that constraint, that consideration was already addressed somewhere. So we pointed out that they could save a lot of money on the program by getting rid of all these extra requirements that were already satisfied or already topics were already addressed. The sufficiency characteristic, if we satisfy this requirement, will we satisfy the measurable stakeholder need? If the answer to that is no, then there's something wrong with the requirement. Yeah, you're getting close, but you didn't actually satisfy it. So we need to fix it. So it's not a valid requirement. And are all stakeholder needs being addressed by the set of requirements? And again, if the answer is no, then something's missing and your set of requirements is incomplete. Lastly, the feasibility check, and this one is also explicit at 2 levels in COSI Guide for Writing Requirements. Can this requirement, in combination with all others, and that gets at consistency and some other things, be implemented with acceptable risk given the budget, schedule, and technology? And this is a recognition that a set of requirements that might be perfectly valid for one kind of a project is not valid for another because of different constraints on budget and schedule and technology. So this is an attempt to place the requirements development in reality to say, can we really do this? So one project I worked on, we had what we thought was a good requirement. Unfortunately, the technology manager told me in a moment of candor, unfortunately, the technology is 2 years behind the schedule. In other words, we didn't expect to be able to mature the technology to satisfy the requirement that was going to be addressed for another 2 years. Well, that meant that that wasn't really a valid requirement because we didn't have 2 years to wait. One comment is don't ignore the hardware, even if it's a software only system. And I see this a lot with my graduate students doing system architecting. They all want to do applications that run on their phones. And I have to remind them that if all you have is a phone, it probably isn't going to do very much unless it can talk to something else. And there are real constraints in the universe, like the physical layer for the communications and the throughput, and how much bandwidth do you need, and what's the capability of the various processors and memory and so forth. So I've grabbed a cartoon from Mayer and Rechten's book, which has an interesting representation of software architecture, which is very interesting in terms of having applications that seem to run across host central processor units. So I'd have a real difficult time figuring out how to actually describe this. But if all you were looking at is the application or functional layer, you wouldn't worry about that. You'd assume, well, something's taking care of that. The problem is the somethings may be so constrained that they can't handle that. There may be too much demand on the network to make an architecture that actually will work. And so the requirements generated, assuming that all this works without any constraints, may actually lead to a failure. So it's important not to ignore the hardware. That was one of the misperception notes I published on LinkedIn. So we can't conclude that software requirements are complete without a concurrent examination of the hardware requirements. And that's why before you write the software requirements, they really better be derived from the architecture and parent requirements and analysis that certainly examines feasibility with respect to the allocations to hardware and other elements of the system. So, summary, clients may not really know what they want until they see something. And that's not to criticize clients, they're just human. Most of us may not understand the implications of a set of functional requirements unless we see it actually realized in a solution. The consultant's challenge or the system engineer's challenge is to elicit and define those requirements. And I use the word elicit carefully here, not to ask them what they think their requirements are, but how they want to solve what they think their problem is and what they think there are constraints on the solution associated with solving that problem and how they're going to measure success. That's what I mean by elicitation. In other words, getting at what's behind whatever requirements they think they have in mind so that the requirements engineer can do the definition of requirements. And once we think we've done that, then we have to validate requirements to make sure that they are verifiable, necessary, sufficient, and feasible. And we went into this in a lot of detail in our 2018 paper. And if we can do this, then we should be able to minimize the rework and improve our customer and client satisfaction. So just a couple of other things, related topics that people might want to know about or may look up to find information if they're not systems engineers. User experience gets into this in a lot of areas, business process analysis similarly. We all know about a bit about system architecting, where we really are trying to establish the client's needs and understand that and satisfy them. Some references. So I benefited from Ivy Hook's book, Customer-Centered Products. She was a longtime member, I think a leader of the requirements working group, colleague of Lou, and a book by Robertson and Robertson on mastering the requirements process. Just be careful about the whole issue of elicitation. It requires more engagement than simply asking the customer what they think their requirements are. So you may need to go in a little more depth on that topic. And here are references to the two papers I explicitly cited before. With that, I'd be happy to take questions, and maybe Tammy can help me moderate the chat list, because I know it's scrolled a lot and Lou has written a bunch and I don't know where the questions are. Maybe Tammy, you could help.
Yeah, there's a ton of comments actually and a lot of back and forth dialogue. So unfortunately, any questions that might have been in there got a bit buried because I don't see a ton of actual questions. A lot of good compliments on your talk, by the way.
Okay, thanks.
I'm going to ask the team, you feel free to unmute or raise your hand or enter in a new chat if you have a new question. And yeah, I'm still not seeing any questions. Sorry.
This is Raymond. Raymond Wolfgang here in Albuquerque. Thanks, Ron. Do have one question. What would you suggest, or how do we sort of implement this type of process when it's we have a situation where the team is savvy with the technology? They feel, I should say, we feel we pretty much know what the customer wants. We've developed this part before, and we're confident we're going to get close enough with our current processes and schedule that yeah, this would be a great idea if we had more time, but we only have 18 months left and we have to deliver. So how do you have you had experience with that mentality, and if so, did you have any tips on persuading for a little more rigor?
Well, some of it depends on the enterprise, right? So, you're talking about what some people call greenfield versus brownfield. We've been doing this for years. We don't need to start from the beginning. Then you examine risk, right? What's the risk of not doing what I described and proceeding with just minor tweaks to the system definition to implement the latest demands from our customer? And your risk analysis might say, it probably isn't going to be a problem because what they're suggesting isn't demanding any brand new technology. In other words, everything's TRL 8 or better, or, it's just very similar to the last thing we did. I used to run into this, of course, all the time at the commercial airplane company. We don't need to do requirements analysis. We've been building airplanes for 80 years or 100 years, right? So there should be some legitimate risk analysis to say, does it make sense to just proceed based on the last thing we did? And that might be the right business answer. But another piece of that could be, are we going to have to do this again? In other words, is there another customer change like this other one? We tried to get some of our programs to think beyond their current customer and bring in systems engineering considerations so that when other customers had slightly different requirements, they wouldn't have to redo everything. And we got ignored. And the next customer that they sold the product to, out of, I don't know, something like 24 software modules, 18 had to be revised to add just a couple of pieces of equipment. Why? Because the software hadn't been architected in a fashion that would allow consideration of different capabilities be inserted and removed. It would have been better, but this is back to the project managers who's saying, I'm only working to the contract. That becomes one of the huge challenges, because you have to figure out somehow how to maybe pay for the systems engineering that allows you to evolve product lines in the business without charging the overhead of establishing the product line to the immediate customer that's paying for a specific implementation. That's a real challenge, because it can only be charged to overhead in those kinds of situations because the current customer isn't benefiting, but you're setting your business up for success in the future. As the name is escaping me, the MBSE guy from John Deere said a long time, 10 years ago at one of the workshops, the first time you do MBSE, it won't save you money. But for the next projects, it'll save you all kinds of money. And the same thing is true in initially establishing a good systems engineering process. It probably, the first time, it won't be cheaper than just tailoring your existing product, but it will set you up for more success in the future. Raymond, I hope that at least partially answered your question.
Yeah, that it did, Ron, particularly the look ahead to, are we going to do this on future programs, which in our case is actually true. We hope to get future programs that are going to be pretty similar. So
yeah, so that's a good business case. But again, you have to sell it in terms of, we may not be able to charge it to the customer, this customer, but this is going to set us up for future success when we get more of these types of things. Other questions?
I just wanted to comment. Why this talk resonates so much with me is, I've worked for a few companies in my career, and it's kind of easy being a supplier, right? You do what you're told, and sometimes better. You see the requirements and you laugh at your prime because they don't make any sense, and you kind of go ahead and you make some assumptions, like you said, and some inferences on what's truly needed, and that's doable. I think the harder case is when you're building something or developing something for the first time, and you are the end game, right? Maybe you're a prime contractor, or you're working for a consumer market, and you've got to all of a sudden work to somewhat of a blank sheet of paper, and nobody's handing you all the requirements anymore. And I think this is the hardest part for a lot of companies as they evolve and grow. So I really like, even though you gave some very simple examples in here, I think they're really relevant, the questions you told us to ask and the thought processes you advised to go through. I think it's really great advice for companies as they're breaking into that kind of business. So I just wanted to compliment you on that. I thought that was a great presentation.
Well, thank you very much. And feel free to just take the checklist. There's 2 pages of checklists. I've posted the PDF in the folder, so you can just snapshot, take those pages and use them as you find that they will help you. Okay, I see a hand raised. Francesco.
Thank you very much, Ron. An inspiring talk, primarily the first part, because I saw in many domains, also in domain where I'm working currently, that people see requirement engineering as a heavy and bureaucratic process, and they are sometimes scared. This is why sometimes they do not provide requirements, or they do not. They are reluctant to collaborate. Would be beneficial to give to this practice a more human flavor, saying that basically requirement engineering, it's a way to communicate in an effective way that maximize customer satisfaction and also value the work of suppliers and also the work of requirement engineer, who basically make sure that the customer understand his or her needs, and also translate this in something that developers can develop and later test. So to give this flavor that is a kind of communication method rather than a bureaucratic heavy process. Thanks a lot.
Yeah, you're welcome. And I didn't say this enough today. I've said it in other talks, but rather than simply trying to write requirements, and I've seen this, I try and use model-based systems engineering to help explain to stakeholders how the system will work. Where the inputs come from, what the functionality is, what the performance attributes. And if I can get them to agree on this is how it works, the sequence of functionality and what they're going to see and how the user interacts, once I've got that model, I can write the requirements. In other words, I don't have to invent things because we've built it into the model, and that's what my MBSE presentations talk about. So rather than going over requirements, I first like to help get with the customer or whomever and say, this is how it will work, or check with them how it will work. We did one workshop, and the first 3 or 4 days were requirements. And then I had an extra day at the end to be able to talk slightly differently about how they wanted the whole sequence to do. But they had a set of requirements that they were working to. And we tried to improve them using our requirements quality measurement and structured requirements. But when we got to the last day and I was showing them in the MBSE tool, this is what I think you're trying to do. And they said, oh, that would have been so much more useful before we started trying to rework the requirements to actually figure out what were the right requirements, because they hadn't thought through their set of requirements from the concept of operations and maintenance and inputs and user and so forth.
Do you see John's question in the chat?
Yeah, I'm looking at it. Should the operators, maintainers be considered as internal elements of the system, like hardware and software, or considered external interfacing systems? Yes. Depends on what architectural level you're looking at and what your scope is. So, I always like to ask, people at the Boeing company, so is the pilot part of the system? And no matter what, the human factors people would say, absolutely. And the FAA would say, absolutely. And I'd say, are we delivering pilots with each tail number? So it depends on what system you're talking about. And that's one of the useful things about the architecture frameworks. We have operational perspective, where we can explicitly include the people, the users, the maintainers, and describe what they do and how they interact with the system. And then we have a system view, which is hardware and software, things that we can produce and sell and have serial numbers, and they are the system with which those humans interact. So the answer is, John, it depends on which system you're talking about, which is why boundary and scope are so critical to get well defined. And I have a LinkedIn note on that as well. Hopefully, John, I answered your question.
Hey, Ron, this is Lou.
Hi, Lou.
Along those lines, it seems like, one of the tenets of systems engineering is the behavior of a system is the function of the interaction of its parts, but also a function of its interaction with the external systems. So it seems like in the modeling world, if we don't include the macro system that our system is in the model, then that behavior is probably not going to be well defined.
Well, that's absolutely true. But you consider especially trying to define functionality at the opaque box level. You say, well, I've got a user interacting with the system. I produce an output, and they're supposed to respond with some input. Well, clearly, let's take Mav's ATM example, because that's what I use in my graduate course. How long should the system wait for the user to provide a response? And what am I expecting the user to do? One of the things I teach my grad students is what those things that you expect the user or the maintainer to do become their requirements. And we don't typically capture them that way, but we ought to. And in the architecture framework, when we have an operational perspective, we have the ability to define and capture and then segregate out. Here's everything the user has to do and how well they have to do it and what the interfaces are they have to interact with. And we lose an opportunity when we simply assume, well, of course they're going to push the right button. Well, how do they know what button if we don't have them engaged in defining the interface and making sure that's the right sequence? And then holding them to that and say, in fact, the last assignment I give my grad students is, deliver for me from your MBSE model the procedures for the user and the maintainer, because they have made assumptions in their system behavior that rely on specific inputs and certain timing and certain sequences and so forth that the model has, and there's no reason not to export it and make it available. The last time I asked people in training systems whether they captured this kind of thing when they were developing system specs as the acquirer entity, I said, you actually capture that when you decompose an operational capability into a system task and a human task? Do you capture the human tasks into a training document? No. Well, why not? Well, we just don't do that. We let the supplier of the system derive 2 or 3 years later all the training requirements based on their system. Seems like a wasted opportunity. We could more quickly get to the answer. Okay, I see Jaime's hand raised.
Yeah, can you hear me?
Yes.
Okay, so I had a discussion with Dr. Carson before about the sometimes blurry line between mandatory and non-mandatory requirements, particularly in the topic of aesthetics. So I remember that case we talk about, for example, the automotive industry, where they have like some well-established ways to quantify, if you want, the aesthetics part of the body of the car. But I wonder if you have any recommendations for other industries like home appliances or things like that, where that perhaps is not a very well-established practice, and you can easily dismiss the expectation of the stakeholders saying, well, the appliance is going to work regardless of the aesthetics, and you can easily say it's not a mandatory feature. But certainly stakeholders have expectations about that, and it's a difficult topic.
It absolutely is. It's like user friendly, right? So, this is where you can use the needs construct. Say, okay, we have the system needs to be aesthetically acceptable, but we have a hard time definitizing that so that it could actually be verified. So, what kinds of things might you do in order to verify that a system actually was aesthetically satisfying to your target market? And surveys and things. So you might actually construct a use case, a specific requirement that says, a certain population has to be positively has to positively respond to whatever the feature is. You could make that a requirement, but it has to be written in such a way that it is verifiable and could be objectively proven compliant or falsified. And that's the rub with these aesthetic kinds of requirements. So I'm not denying that there may be a mandatory criterion, but you have to, okay, it's got to be aesthetically acceptable to whom, under what conditions, etc. And how are you going to verify that becomes critically important. Are you going to ask your kids whether they like the shape of the car? That maybe that would work, but that's probably not your target market, since my kids never had enough money to buy a car. So you might have to construct a specific verification case. You might not make that a system requirement and put that on a supplier, but you might make that a marketing requirement for constraining certain interfaces, and then making those constraints requirements, like it's got to have this shape because we've proven that out. And that's a good use of a design constraint, is we've proven something out, just make it like this and we'll take all the risk. And that's a feature of a design requirement. And I talked about that in the 2015 paper and a little bit more. Let's see, I'm looking at the comments to see if there's any more requirements or any more questions. So John's got another good comment from regarding 632. Okay, I'm not seeing any more questions. Did I miss something?
I don't see anything more.
Okay.
I'm going to thank you very much. It was a really engaging discussion. I'm going to stop the recording.